How strong is concrete?
Well, when we talk about concrete strength, we're normally referring to its compressive strength. In other words, how much force it can stand pushing down on it. And that's one of the most important characteristics of concrete for use in practice. So taking this cube, when it gets to an age of about 28 days, I would expect it to be able to carry a load of at least 30 tons before it failed.
What happens if you put too much compressive force on concrete?
Well, the best way to answer that is to actually look at a cube being loaded in a compression machine. So here's a 100mm cube. The concrete's 28 days old, and the load is about to be applied to it by the steel plates that are in contact top and bottom. And the load is now being applied, and the failure is sudden, as you can see. So now we're going to look at this in slow motion, and you'll see some water appearing at the top of the specimen that has been squeezed out of the concrete. And in the same region, cracks are just beginning to form, and then there's a sudden brittle failure of the entire specimen with the concrete falling away.
How stiff is concrete?
Stiffness is a measure of how much a material deforms under a compressive load. And concrete is very stiff. And this is important because it means that concrete in structures doesn't deform too much under load. Looking at the load deflection graph for the test you have just seen, the cube carried a load of over 40 tons with a deflection of just 1.5 millimeters.
Does concrete have any strength in tension?
Yes, well, it does have some tensile strength, but if I were to pick up a concrete specimen and try to break it by pulling on it, I couldn't apply enough load. But if I were to hang weights from it, then it would fail at a load much lower than the load required to fail it in compression, at a load of about 10% of that required to fail in compression. Now, why is that? Well, when concrete is loaded, tiny microcracks form in the concrete. And when the concrete is loaded in tension, those microcracks open and lengthen, and that reduces the area of the concrete that is carrying load, which causes the stress to increase, and the specimen fails very quickly. In contrast, when the concrete is loaded in compression, the cracks are squeezed, they lengthen more slowly, and have much less effect. Of course, concrete can be reinforced to increase its strength in tension, and we'll hear more about that in the Bare Essentials of Reinforced Concrete series.